Okay, these are the derivatives of the hyperbolic functions, and you can review what the hyperbolic functions are if you need to, but I'm just here to show you how to find derivatives involving hyperbolic functions. So the hyperbolic sine of u is, the derivative would be a hyperbolic cosine of u times u prime. The hyperbolic cosine of u would be the hyperbolic sine of u times u prime. The hyperbolic tangent of u would be the hyperbolic secant squared of u times u prime. The hyperbolic cotangent of u is minus the hyperbolic cosecant squared of u times u prime. The hyperbolic secant of u is minus the hyperbolic secant of u times the hyperbolic tangent of u prime. And then finally, the hyperbolic cosecant of u is minus the hyperbolic cosecant of u times the hyperbolic cotangent of u prime. So let's apply these formulas to some functions. So let's say I want to find the hyperbolic sine of x cubed minus 1. Well, if you go back and look at the formula for hyperbolic sine of u, that's simply the hyperbolic cosine of u times u prime. So basically, I would just have the hyperbolic cosine of the argument x cubed minus 1, and then I would multiply by the derivative of u, and u is just this argument x cubed minus 1. So the derivative of x cubed minus 1 would simply be 3x squared. So then my result is just 3x squared times the hyperbolic cosine of x cubed minus 1. So in this case, the u was x cubed minus 1. Now this one is actually a little bit different. This is the natural log of something. So the first thing I have to think of is, how do I find the natural log? How do I find the derivative of the natural log of u? Well, the derivative of natural log of u, remember, is 1 over u. So I would put 1 over the hyperbolic tangent of x here, because that's what my u is. And then I would multiply by the derivative of hyperbolic tangent of u, or x in this case. And so the derivative of hyperbolic tangent, notice up here, the derivative of hyperbolic tangent of u is hyperbolic secant squared of u times u prime. Now we don't need the u prime here because the argument of the hyperbolic tangent is just x. So the derivative of hyperbolic tangent of x would just be the hyperbolic secant squared of x. So you would just get secant squared of x times 1 over hyperbolic tangent of x. Now, I went ahead and showed you that we could actually simplify this a little bit using some rules. The 1 over the hyperbolic tangent can be written as hyperbolic cosine of x over hyperbolic sine of x, and secant squared of x, hyperbolic secant squared of x can be written as 1 over hyperbolic cosine squared of x. So you might have to look up those properties, but trust me, that they can be written that way. So now, if you write this way, then you get hyperbolic cosine of x here that goes into this hyperbolic cosine squared, and so you'll get hyperbolic cosine of x down here with hyperbolic sine of x, and so that's going to be 1 over hyperbolic sine x times hyperbolic cosine of x, and 1 over hyperbolic sine x is hyperbolic cosecant x, and 1 over hyperbolic sine x, cosine x, is hyperbolic secant x. So, you know, it may not be that big of a deal, but I just wanted to show you that you can use properties of hyperbolic functions to simplify a hyperbolic function. But anyway, that's your derivative. So either one of those two check marks will probably be fine. Just depends on if your instructor wants you to take it further and simplify it. Okay, and then I'm going to do one more. This time I'm going to do hyperbolic cosecant, where u is e to the 5x. So let's go back and look at the formula for hyperbolic cosecant. That would be this one. Okay, so the formula for hyperbolic cosecant of u would be minus hyperbolic cosecant u times hyperbolic cotangent of u times u prime. So this would be hyperbolic cosecant u. I actually got this written wrong, so let me correct this real quick, because these x's should involve the e to the 5x. Okay, I've got it fixed now. I had an x instead of what I should have had, the e to the 5x. So the derivative of hyperbolic cosecant of e to the 5x would be minus hyperbolic cosecant of e to the 5x times hyperbolic cotangent e to the 5x, and then times the derivative of e to the 5x, which would be 5e to the 5x. Now in the last step, I just moved the 5e to the 5x to the far left, and I wrote it as minus 5e to the 5x times the hyperbolic cosecant of e to the 5x times the hyperbolic cotangent of 5x. And that fixes it. Okay, so that's derivatives of hyperbolic functions. And then in the next video, I'll show you how to find derivatives of inverse hyperbolic functions.